Hi. I'll start with a short introduction of Cortica. Cortica is an AI company that was founded in Israel about 10 years ago. The foundation of the company is actually based on a research from the Technion, Israel Institute of Technology. And the goal of this research was to try and identify what are the gaps between the most advanced artificial intelligence systems and the capabilities of the human brain and the human cortex. Specifically, back then, about 10 years ago, the researchers were trying to understand how the basic minimal units in the mammal cortex perform different perception tasks, such as recognition, classification, understanding of the real world through sensory inputs. And the idea was to try, instead of inventing another generation of AI, trying to mimic those biological principles by using mathematical models and software that can later translate to technology that can enable different platforms. 10 years further today, we are focusing on development of this technology and integrating it into various autonomous platforms, such as autonomous vehicles, drones, smart cameras, and many others smart machines. What I'm going to show you today is to talk a bit about a technology, what we call autonomous AI. So while we all know that there is a revolution today in a shift from platforms that are operated with a high dependency on humans to a platform that are fully autonomous, it's important to talk about what this means to AI, what it truly means to be autonomous AI. So let's look at two different systems. One system is a deep learning system. As you know, deep learning is today the state of the art of AI. There was a major shift around 2012 where there was a convergence between significant compute power that was available for us and enough data resources which make this technology more useful. The technology was invented already about 40 years ago using neural networks, mathematical models that you can train by using data instead of programming. And those deep learning networks allow us to use labeled data and turn it into a system that can react in real time, can understand signals, for example, recognize different objects, and enable systems like autonomous cars. However, these systems, and that's what we are challenging, are still far away from human capabilities. One example is the word deep. All those systems require a lot of compute power today. They are based on deep architectures, a lot of layers, which is still very different from how our brain operates. Our cortex is based on 6 layers and is extremely parallel. Another major difference between deep learning and biological systems like the cortex is the ability of our biological system to learn in an unsupervised way. We don't really need a lot of labeled data to train those systems. We just observe the world around us. We are able to cluster different patterns to identify commonalities and form what we call concepts about the world that later help us to understand and process in real time. So the goal of Cortica is to try to merge those two disciplines, to identify what are the gaps between the cortex and the deep learning and create a new generation of AI system that is more autonomous, that is based on unsupervised learning. As you know, the world is shifting to autonomous platforms, and this goes much beyond autonomous vehicles. We are talking about explosions of cameras. There are millions of cameras in cities today. There is a strong focus today, especially in China and India, but we see this trend spreading to Europe and US, where those cameras generate literally big data of visual inputs every second. We are generating trillions and trillions of images, and those images have to be analyzed to make all this data useful. Of course, there are other areas such as intelligent drones or screening machines that you have in airports, and all of them need this kind of AI that is not programmed in advance, that is not predefined with a task, but can autonomously identify different anomalies to generate those concepts and to learn on its own. New areas such as retail, robotics, medical images, all need some kind of AI that is capable of processing not just unstructured data, but extremely complex sensory data, whether those are CT or X-ray, and automatically identify different commonalities and patterns. So to give you just a perspective about where we are on this AI revolution roadmap, So the traditional approaches until about 2012 were based on classical paradigms. For example, computer vision. When people wanted to design a very strong computer vision system, they first used features that were predefined. So PhDs or researchers thought about some useful features. For example, to detect a pedestrian, they were detecting a head, a hands, or a body structure. And then we're using models to compose those features into some sort of classifiers. Around 2012, as I mentioned, there was a major jump and a shift of paradigm to approach of learning, deep learning. Instead of generating those systems in a handcraft manner, the approach started to focus on a learning approach using neural networks. However, we challenged this approach, and we believe that around 2020 there will be another shift, and the shift will be mostly pushed by the requirement of autonomous platforms. What is autonomous AI? As we discussed briefly, this is more about unsupervised learning. We are not interested anymore having people in the loop while training those systems. We want the AI to observe the world on its own, to identify different commonalities, and to learn without any supervision. So a few words about the technology of autonomous AI, as we believe this is the next generation of AI technology. Here we have several building blocks or several pillars upon which this technology is based. So the first one, and the most interesting one, is that we are solving a different problem than recognition. Usually when people talk about neural networks, they are solving a problem of classification. So the neural network is fed with a lot of labeled data, and then it can just reproduce the training set that was used for the purpose of teaching the system. In the case of the cortex, and in the case of autonomous AI of cortex technology, we are trying to address a very different problem. The problem is how we can generate generic representations of the world that are not limited to a certain problem, that are not limited to detecting a chair or a cat or a pedestrian, but we can take a sensory input, such as images, and compress them into what we call conceptual signatures. The signatures have to be generic in an aspect that we can do anything with them without going back to the original signal. They have to be searchable. So if I take a picture of this room, I can use the signature and ask various questions. Who are the people in the room? What are the objects? What people were wearing? What was the light in the room? And so on. And again, without going back to the image. So this is the main building block of cortex technology, where we compress the sensory input and then use the compressed representation, not for the purpose of reconstructing the image, but for the purpose of executing all the perception tasks within the compressed space. The second pillar, once we created those compressed representations that are truly generic, we can shift and reverse the whole pipeline of learning. Instead of starting from a problem definition, from labeling or keywords, we can start just from random inputs. We can generate those signatures and let them self-organize, let them intermatch, find commonalities within random set, and eventually form what we call a concept. The third and very important aspect of this technology is how the knowledge is being represented and aggregated in the system. One of the main challenges today of a deep learning approach is that every time you start a new task, you start from scratch. You train the system to recognize a cat, you shift to recognize a pedestrian, and you start from scratch. The system learned to play chess. If you want to play Go, you need to train it again and again. We believe that as humans, and that's what we succeeded to implement in the system, we are able to transfer knowledge very effectively from one task to another. And this obviously reduces the amount of data that are required to learn new problems. Here are just some limitations of deep learning that I already talked about. The most obvious one is a supervision. Of course, we shifted from computer vision or handcrafted features to a learning approach, but still deep learning is highly dependent on humans. The system is as good as the labeled data that was generated by humans, and we want to shift from that. Another big challenge of AI today is that neural networks are actually black boxes. So even when they perform better than humans, when there are some mistakes, it makes people, especially in autonomous vehicle space, extremely nervous, because it's very difficult to predict when the error will reoccur, how to fix that, and how when we fix that, we are not jeopardizing the previous knowledge, so new errors will not appear. To summarize a few key advantages of autonomous AI compared to deep learning. So the first one, we are truly interested in AI that will learn things that were not predefined. The whole magic is not training the system and explaining it everything we know, but let the system discover concepts and entities and relationships that were not predefined to it. The second part, the essence of the matter, is the learning part. We are talking about unsupervised learning, but moreover, once we have the learning that is based on signatures, there is no superficial division between the learning and the inference part. It's all about generating signatures, matching the signatures to a database that was generated, and then having new signatures forming new concepts. So the learning can be implemented in real time. Closed loop is extremely important. So we want our systems, such as drones or autonomous vehicles, to adapt to situations. We want a constant feedback loop that will make the AI learn in real time and change and adapt to situations. I talked about predictability, not having a black box, but being able to understand the AI, establish some sort of language with the AI in a form of those signatures, where we can predict and understand how the information is represented. The last, and also quite important, is the collaboration between different AI entities. Today, deep learning is quite an isolated box. When you have one deep learning system and another one, the combination between them is not trivial. Furthermore, when you have multiple modalities, such as different sensors, LIDAR, radar, camera, and many of those, one of the challenges is how to fuse all this data and leverage the vast amount of sensory input. Using autonomous AI, we generate unified signatures, so we merge all this information into a single representation. And just to finish with a few words where we believe the AI world is going. People talk today about narrow AI today, AI that is very effective in playing Go, in playing chess, and driving cars. And the vision is that the next big leap is going to be around generic AI or general AI, what is being called AGI. However, if we go back to the origins about our best reference of intelligence, which is a human intelligence, we quite see surprisingly that there is not sure there is such a thing, general AI. Even a human intelligence is composed of a set of narrow intelligence that are merged and collaborated quite effectively. So we are talking about logical intelligence and music intelligence, and many types. There are different definitions and divisions, but it's all about a set or multiple intelligence combinations that eventually form what we as humans can do. So we believe that the next big leap is not necessarily shifting from what we have now and the unique capabilities of letting the artificial intelligence to operate extremely complex systems like autonomous vehicles and to generalize it to something mystical. We believe that the next big thing of AI is autonomy, really embedding the autonomy into the learning processes, into intelligence of artificial systems. Thank you very much.